Welcome to my algebra class. We're on Chapter 9, Section 1. In this chapter, we're going to be solving systems of linear equations. A system of linear equations will be two or more equations of the same variables. For example, x plus y equals 3 and y equals 3x plus 1. That would be a system, because we have two equations and we have the same variables in both. To solve a system, we have to find all the ordered pairs, so we're in the coordinate plane, Cartesian coordinate plane, that make both equations true. And there are several methods of doing this, and the first method we're going to learn is the graphing one, which is great if you've got a graphing calculator and you're precise, but not very good if we're human. But we're going to try it. So here, method one, if we're doing graphing, we have three possible things that can happen with two lines. The lines intersect, and they have one solution. They are running parallel, they have no solutions, or they coincide, they're actually the same line. They have infinite number of solutions. So with that in mind, we're ready to start the evens. We're on page 414, oral exercises 1 to 9, written 1 to 18. So heading on your papers, skip a line, title, and we're starting with the oral exercises. And they say, state whether the given ordered pair is a solution of the system. And number 2 has the ordered pair -1, 4, and we're going to test it to see if it solves for x plus 3y equals 8. And the other equation in the system, 2x plus y equals 0. So plugging in these values, this is x and this is y. So 4 times -1 plus 3 times 4. See if that equals 8. That's -4 plus 12. And 8 equals 8. So it works for that equation. Now we're going to have to see if it works for this one. So 3 times -1 plus 4 has to equal 0. We get -3 plus 4, and that's 1. And 1 does not equal 0. So no, that ordered pair does not solve both equations. Therefore, it doesn't solve the system. Problem number 4, state the solution of each system. So in number 4, we have this graph of this system. We have this line, and then we have this line. And they intersect at this point right here. And that is the solution to the equation. So that would be x is 2, y is -1. And I'm off of here. The numbers mess me up. Okay, number 6. We have, on number 6, you have these lines drawn on the graph. You have this one, and you have this one. And they meet at, they intersect at this point, so they have a solution which is -1, -3. Problem number 8. If a system has no solution, what do you know about the graphs? Well, if you go back to our information or your notes, if it has no solution, then the lines are parallel. Okay, now we're ready for the written exercises. Number 2, we're going to solve each system by graphing. In order to graph it, your equations must be in slope-intercept form. And on the notebook paper, I want you to do the work to get them in slope-intercept form, and then get graphing paper, because you need it in order to graph correctly, to find the exact point of intersection. So graph paper to graph, notebook paper to get it in slope-intercept form. And make sure you do a separate coordinate plane for each problem. So number 2, we have y equals negative x and y equals x plus 9. Now these are both in slope-intercept form, so we can go directly to our coordinate plane. And this one has an intercept of 0, 0. And its slope is negative 1, so it's down 1, right 1. And we connect that with a line. Make sure it goes right through the points. And if it doesn't fix, on mine I can fix it. It's still off. And the second one has a intercept of 9, 0, 9. So here I'm going to have to guess 0, 9. So here's 6, 7, 8, 9. So the intercept is at 0, 9. And the slope is 1, so it goes up 1, right 1. And I make my line. And on this graph, it looks like it's intersecting. I'm going to move it a little bit. I would check the answers in the back of the book to make sure you're getting it. This is cheating a little bit, but I didn't get the coordinate plane big enough. So anyway, the intersection, just check the back of the book, is right here, which is, and go back to your notebook paper, negative 4 1/2 and 4 1/2. Or 9, negative 9 halves and 9 halves. Okay, problem number 4. We have y equals 3x plus 1 and y equals 3x minus 8. So they're both in slope-intercept form. I'm graphing them. The intercept is 1, so we put a point at 0, 1. And it goes up 3, 1, 2, 3, right 1. And we connect that with a line. If it doesn't go right through it, then we're going to have a problem. Okay, and the other one has an intercept of negative 8. Here's negative 7, negative 8. It's too far down. Negative 8. And a slope of 3. 1, 2, 3. And right 1. So here's our second point, and draw a line through that. And you can see, well, maybe we can't move this thing over. The lines are parallel. So the solution is no solution. They share nothing. Problem number 6. We have 4x plus y equals -3. And we have 5x minus y equals -6. So we got to get these in slope-intercept form. So we'll subtract 4x from both sides. We get y equals -4x minus 3. Subtract 5x from both sides. We get -5x minus 6. I still have the negative sign. So multiply by -1. I get y equals 5x plus 6. And go to your graph paper and graph these two lines. First one, the intercept is 0, -3. And the slope is -4, so we go down 4. 1, 2, 3, 4. And 1 to the right. Connect that with a line. And then the other one has an intercept at 6. So we put a point at 0, 6. And its slope is 5, so it goes up 5. 1, 2, 3, 4, 5, right 1. And this is estimating, so I'm probably going to be off here. If you check the answer in the back of the book, it says that the intercept is -1, 1. So keep that in mind when I graph it. It's got to go through here. And this is, again, kind of cheating. So I was off on that point. This point needs to be moved over. So our intercept is -1. Our intersection point is -1, 0. And that's our, excuse me, it's -1, 1. Hang on a second. Should intersect right there. Okay, -1, 1. Now when you do this on a test or a quiz, try to figure out which point looks like it's going to be, and then you can just plug it in and see if it works. So -4 times -1 is 4, and 4 minus 3 would give you 1. If it works, you got it. And here, if you put in -1, you get -5 plus 6 is 1, and that makes 1. So it works for both of them. And number 8. We have our coordinate plane. And we have -2x plus y equals -1. And x plus y equals 5. The first one, getting it in slope-intercept form, y equals, add 2x to both sides, 2x minus 1. And the second one, subtract x, we get y equals -x plus 5. So the first one, its intercept is 0, -1. The slope is 2, up 2, right 1. And connect that with a line. And lengthen that line a little bit. Oops. And the second one has an intercept of 5, 0, 5, and its slope is negative 1 down, 1 right, 1. Connect that with a line. It looks like the intersection is at 2, 3. This one worked out great. So here's our intersection. So this ordered pair that works for both is 2, 3. And you could plug it in and check it. Problem number 10. We have 2y minus x equals 2 and x minus 2y equals 8. Solving for y, we get 2y add x to both sides equals x plus 2, divide by 2, and we have y equals 1/2 x plus 1. The second one, subtract x from both sides, we get negative 2y equals negative x plus 8, divide by negative 2, and we get y equals 1/2, negative 1 divided by negative 2 is 1/2 x. 8 divided by negative 2 is negative 4. Then graph that. So we get the intercept is 0, 1. The slope is up 1, right 2. And we draw a line through those points. And the second one is the intercept is 0, negative 4, and it's up 1, right 2. And we draw a line through those, and we can see that they're going to be parallel. So there's no solution. And problem number 12. We have 6x plus 4y equals 2, and 3x plus 2y equals 1. Solving for y, we get 4y, subtract 6x from both sides, we get negative 6x plus 2, divide by 4, and we get y equals negative 6 over 4 is negative 3 over 2x. 2 divided by 4 is 1/2. And the second equation, 2y equals subtract 3x from both sides, divide by 2, and we get y equals negative 3/2 plus 1/2. So we actually have the same line. So all you have to do is plot the one line, and since they're the same, they're going to have infinite number of solutions. So our intercept is 0, 1/2, and we go down 3, 1, 2, 3, right 2, 1, 2, and there's our second point. Connect those 2 points in a line. And since we would just be plotting the same line again, we just say that these things drawn right. There's an infinite number of solutions. We're going to skip 13 through 16. They involve halves. And then we're doing 17 and 18. And number 18, the graphing method of solving a system of equations is particularly useful when the equations are not linear. So we have 2 parabolas here in both of these. Estimate the solutions of each nonlinear system below by studying the graphs. Check whether your estimate satisfies both equations. So you could actually plug the numbers in and see if they work. Well, 18, if we look at where the parabolas intersect, one of them is at when x is 1 and y, it's going right like this. And the other one's going well, this one of them intersects there, so that's going to be 1, negative 1. And if I drawn this correctly, the other one's intersecting up here at 3, 3. So 3 would be our other solution. And you could plug them into the two equations, they would work. That concludes the evens. Be sure and check the back of the